Hello, everyone. Welcome to the second virtual STEM fair. Thank you all for joining with us today, and I hope everyone is doing great. At the start here, we had some small technical difficulties, but it seems like we're doing fine now. So let's begin. Hi, my name is Sri Kairanti, and I'm a rising sophomore, and I'm the organizer for this event. I wanted to bring the opportunity to other students to present and enhance their skills in STEM during the COVID-19 pandemic so that they can also develop their speaking skills and their presentational skills. We had a great first event on June 28th, and this is the second event, and the third event is on August 9th. I have had a great response for the upcoming August 9th event, and I plan on organizing more events in the coming months. I am also going to be announcing the fourth event date soon on my site, so stay tuned for that. At the end of today's fair, I will also explain how to sign up, how to be part of the next fair, and how I help the presenters through the process. We have a lot of exciting topics that will be presented in today's event, and we have an exciting couple of hours ahead of us today. But before we jump into the topics, we have a message from our guest speaker, Professor Mike Ellis from UIC, or the University of Illinois at Chicago.
Hi, everyone. I'm Joe McAllis. I am an assistant professor at the University of Illinois at Chicago in computer science and the learning sciences. And I have a PhD in learning sciences from the University of Wisconsin, a master's degree in science instructional leadership from Illinois Institute of Technology in Chicago, and a bachelor's degree in philosophy from Wisconsin. And now I design robots. I build educational social robots to work with kids to help support their learning and interest in STEM fields. But then I was a first generation student in all of the degrees that I got. I was the first person in my family to complete a bachelor's degree, a master's degree, and a PhD. And this guy, when he graduated from high school, didn't think that a four-year college was for him. I grew up poor and sort of disenfranchised in ways that made me feel that I just didn't belong in a college like that. I had a high school GPA of 2.47, and my only thoughts were that maybe I could do something like culinary school. It took a little while, but I had a lot of friends and family who encouraged me to think about a four-year college and to advance my understanding and my education. And I thought, okay, so I went to Wisconsin, and I thought maybe I would become a chemical engineer. And in my mind, and in like many people's minds, this is what it looked like. Some guy in a lab doing some things with other things, with test tubes and beakers and that sort of thing. And the more I got to realize what chemistry was like in this environment, I realized that it wasn't for me. Not that it's not for anyone, but it wasn't for me. And so I completed my degree in philosophy, and I became a science teacher. And I coached an after-school robotics club. There's me. And I worked with amazing students. This is Nick, who is one of my first graduates, and he now has a mechanical engineering degree from Howard University. I also met some incredible mentors like Brittany, who was the person who really encouraged me to go back to grad school. And the way she told me that she thought it was right for me wasn't that I was so smart or that it was going to make this big change in my life or money or anything like that, but that I'd really like it. And that kind of sold me. And so after Googling some things, I ended up, after a while, starting my degree in the learning sciences, which was something I hadn't known even was a thing until about 10 minutes before I sent in my first application to be a learning scientist. One of the amazing things that happened along the way to my PhD in learning sciences is that I saw just how broad the world of STEM was. And I started to reach out and hear from people like Ayanna Howard, who's a roboticist at Georgia Tech now and used to be at the Jet Propulsion Lab, who was one of the pioneers in human-robot interaction. And her work really helped me understand how it is that people interact with machines and that could be a whole thing you studied. And it was really inspiring. Other people like Jean Yang, who set out on her own to start her own software company because she realized there was huge gaps in what people were being offered, and she wanted to be able to do her thing her way. Joe Towles, who was the first person I collaborated with at Wisconsin, and he really showed me the power of those collaborations. And Flavio Azevedo, who's become a really important mentor in my life, who really demonstrated to me how powerful our work in our own lives can be in the lives of others. And I've kind of collected all these experiences to start to do what it is that I do. One of the other things I realized is that what I do is not always an obvious thing that's a STEM career. That STEM careers take all sorts of shapes and sizes. And sometimes that lab in science isn't in a building, but it's out in our world and trying to make that world a better place. Sometimes chemists don't work in chemistry labs. They work in breweries or other places in fields that chemistry is really important and crucial to make our world a better place, or sometimes a more fun place. And we can also work in labs to build things like robots or machines and technology that work with people or help people. And all these sort of things, all these experiences really built, from my understanding, to recognize just how important diversity in and of STEM was, that anyone can be part of this, anyone can be in STEM, and what it is to be in STEM can take all sorts of shapes and sizes as well. And so now I get to work with kids and robots and help kids learn with those robots in ways that to me appears magical and amazing every day. I love what I do, and I never could picture what this was without all the experiences I had and the diversity of people in my life to help get me here. Never in a million years would I have thought this kid would become this kid. And so when I had an opportunity to come talk to you at your virtual STEM fair, one of the things I really wanted to highlight was just how important it is for everyone to understand that no matter who you are, you get to be who you are in STEM. And that no matter what it is that you do or what it is that you like to do, you can find a way to be what you want in STEM. And the last thing is that this isn't always obvious for people like me, people like you, and that along the way, as you're working towards these things, it may also be really important for you to help others to see themselves here too. And when we do that, we can make this place an important and powerful tool for everyone to feel that it's something for them and about them. So thank you all for being here. Thank you for the work you're doing in this virtual STEM fair, and good luck.
Thank you, Professor, for that amazing, inspirational information. Now, let's take a look into topics that will be presented in today's event. First, we have augmented reality, then an overview of AI, machine learning, deep learning, and data science. Then, how is AI used in robotics? How does an electric motor work? Math and computer science, the science behind DNA, and then finally, 3D printing. So it looks like we have some great topics in store for today's event. Also, check out my website, stemfairs.com, for information about future events. The event is being recorded and live streamed, and the recording of this event will be posted on my YouTube channel, STEM Explorers. So share the link with others and remember to like and subscribe to my channel. Please hold your questions until the end of each presentation and then type them in the chat. And then I will ask them to the presenters as they cannot see the chat. So let's begin with their first presenter. She will be talking about how augmented reality works. You can start presenting.
Hi, everyone. Hopefully you're having a great time and a good day. My name is Renika Maram, and I'm going to be an 8th grader in Daniel Wright Junior High. Today, I will be presenting about augmented reality. In this presentation, we will learn about the importance and value of augmented reality, AR. As you can already see, 3 pictures on the front of the page: Pokemon Go, IKEA furniture app, and education. All these are 3 key components of augmented reality and your daily fun life. So let's start. First, there's so many different types of realities. What's the difference? Well, AR is augmented reality, VR is virtual reality, and MR is mixed reality. They're all some type of reality, but they have their own minor differences that make them each unique. So first, VR. VR implies a complete immersion experience that shuts out the physical world. So basically, it's like fantasy. You can imagine your world that includes your characters you want, the setting you want, and the magic. For example, like you're on cotton candy land, eating cotton candy and having all the gummies on earth you want. Like, that's VR. You can imagine that. But AR is when you have physical contact with whatever you're doing. So for example, Snapchat filters, the stickers, all of those are, you have physical touch with it. So for example, you scan a problem, you have your hand on the screen and you have physical touch with it. It's not like fantasy. It's not that you wait. It's not in your imagination. And finally, MR is a mix of AR and VR. This is a project that they're slowly working on. It's not yet like fully, it's an idea. It's not yet presented. So what is augmented reality? I already gave you an overview. Like I said, it's something you have physical. So let's get right into the examples. Pokemon Go. 2 years ago or so, Pokemon Go came out and a lot of kids, teens were obsessed with this app. It's an adventure app that takes you on quests, which leads you to higher levels. So what you do in this app is basically you get challenges and quests and you go to find them in the woods or wherever nearby it is. So this is augmented reality because you have physical touch with it. It leads you, it takes you through a map to go see it. Next, Snapchat filters. Almost every teenager or maybe even younger has this app. There's filters like a dog, a devil, you can look like a cherry, you can look like Shrek. Any kind of character you imagine, you can look like based on Snapchat filters. Google Pixel Star Wars stickers, they're 3D stickers that bring so much joy into little kids' life. Any type of character you want, for example, Mickey Mouse, Donald Duck, Pluto, the dog in Mickey Mouse. Any kind of character you want, you can find a sticker on the AR apps. And finally, the US Army. Our future soldiers that are going to protect our country have to go through simulations which are created by augmented reality. If they want to have the real experience, what war, whatever they're fighting for our country is, they have to have practice simulations that help them know exactly what to do. So augmented reality comes into a big role right there. All right, so every single computer vision, every single virtual reality or any reality has a component called computer vision. It's very critical, the component. Without computer vision, AR is not possible. So computer vision is a field of computer science that works on enabling computers to see, identify, and process images in the same way that a human vision does. Because it's a computer vision, it cannot identify it directly. So if we see a book, we can recognize it's a book. We say a cherry, we'd be like, that's a cherry. But a computer has to go through a scanning process to recognize that's a phone. It can't just look at it and recognize it like human vision. So that's what computer vision is, and that's how augmented reality works. So the next, I have the process and steps of augmented reality. As before, first you have the app, then you scan the image, which tracks it, then it detects it, it describes it, it matches it to exactly what you scanned, and it gives you an estimation, and finally puts out a visualization for you guys. So it labels all the parts, it tells you what's broken. For example, you have a problem in your sink and a water pipe is leaking, but you don't know that where exactly the pipe is leaking till you scan it with the AR. It automatically directly tells you the problem, and you can also link it with the handyman workers so they know exactly where the problem is so they get their tools right. So the next one is the top 8 uses of augmented reality. I've already mentioned like Snapchat filters, US Army, but there's way more to augmented reality than you think. So medical training is very similar to US Army, but they have to train on parts of the human body so they don't kill the person when they're doing surgery. It's very, so that's their practice tool. Next, retail. Customers shopping in the store can have a clear view of what they're buying, including having all the parts labeled. For example, like in this time, COVID-19, not many people want to go to the shops to shop for clothes, so they look online. If there's like a dress or any type of clothing you want, you can scan it with AR and the parts will be exactly labeled. So for shorts, if you don't see a button, it'll tell you there's a button there. So it's very helpful. Next, repair and maintenance. This is very, very similar to the sump pump situation I gave you guys before. So yeah. The next is design and modeling. People that are into fashion have it easy due to AR. They can create their clothing and have a model any type of body type they want on the AR app, and they can test their clothing designs they make onto the body type that they have. So they'll know how it might look on everybody. They don't have to have actual models, even though they will model it after. Our next component is business logistics. AR presents a variety of opportunities to increase efficiency and cost saving across business logistics. It will help with anything near transportation, warehousing, and route optimization. It's pretty self-explanatory. Next, we will go on to tourism industry. AR presents a huge opportunity to all traveling industries. Any place you want, you can visit and you can view in AR. You might think that why would you use AR when you want to go on a vacation? Well, I've heard a lot of things from my friends saying they go to Paris and all they see is the Eiffel Tower. And over here, from my point of view, they're like, Paris is so cool. Like, there's so many things to do there. You can check it by using AR in beforehand, not spoiling the whole vacation for you, just to make sure that you have a lot of sites that you want to visit, activities to do there, and have a nice planned ahead trip. Classroom education. As you can see in a couple of the pictures on the screen, classrooms are already using AR. In the next generations, AR will be in every single classroom, including kindergarten and preschool. It's just this how technology advances. And finally, public safety. With the AR app on your phone, there's also AR glasses, AR watches, anything you can think of on technology. People can be aware of anything dangerous in their surroundings. So they have their phone in their pocket and they scan it accidentally. It'll beep and it'll be like something's bad there or something's dangerous there. It'll tell you. A moment to look at the pictures. All right, so for this next part, I have a slide here. Just look, providing some housing tips. So you have an empty rug and you're like, oh my God, what furniture might look good here? You scan a furniture, you find a furniture from the IKEA app or whatever, and you place it in the app and you can exactly see how it might look on your rug. So there's no need there will be a need when you buy the furniture, but you can see in beforehand how it might look. So do you guys want to use augmented reality today? Well, App Store has a bunch of AR apps, as I listed below. There's Arvid Augmented Reality, Adobe Aero, AR Magic, many more apps. I just went back. Okay. So you can get AR apps based on your interests. It doesn't have to be Angry Birds. You don't have to do it based on that. And my interest sparked in AR when I got to know that Snapchat filters are augmented reality. I recently got Snapchat about 4 months ago, and I love the devil filters, the dog filters. They're all really fun to use. And once I got to know that they're AR and that AR has so much more than just what you see, I had a lot of fun researching this, and I'm really happy that I passed it on. And as you can see on the right, I have a couple of pictures using the filters with my friends, a couple of those fun stuff. And finally, any questions?
Thank you, Varnika, for that amazing presentation. So if anyone in the audience has any questions, please type them in the chat, and then I will ask them. I'm not seeing any questions so far. I'll wait one more minute and see if anyone else has any questions.
Okay, cool.
Someone is asking, what is mixed reality?
Okay, so I said mixed reality again, and I'll say it again in the beginning. It's a mix of virtual reality and augmented reality. So you have physical contact with your fantasy imagination.
Okay, thank you for answering that. Okay, it seems like no one else has any questions. So thank you for presenting and thank you for answering that question.
All right. Hopefully you guys try AR, and thank you for listening. Hope you learned something.
Our next presenter, Deepika Shri, she will be presenting about an overview of AI, machine learning, deep learning, and data science. So take it away, Deepika Shri.
Hello, this is Deepika Sri Dhananjayan. I'm going to be in 8th grade in Aptakisik Junior High School. Today, I'm going to give you an overview of 4 aspects. The first one is artificial intelligence. The second one is machine learning. The third one is deep learning, and the last one is data science. What is artificial intelligence? Artificial intelligence is also called as AI. AI is a powerful machine that analyzes data quickly and is able to mimic human-like decision-making behavior. Simply saying, we, as humans, enable the machine to think. The most popular coding language in artificial intelligence is Python. Python is a coding language that is really easy to learn and would be really helpful later on in life, like college or work. It is also very helpful in machine learning and data science. Some of the best examples to describe AI are a self-driving car, Alexa, and Siri. This is just a brief introduction to AI. What is machine learning? Machine learning is a subset of AI. Machine learning provides systems the ability to automatically learn and improve from experience without being explicitly programmed. It focuses on the development of computer programs that can access data and use it to learn for themselves. Machine learning provides us statistical tools and lets us explore and analyze data. The most popular coding language right now in machine learning is Python. Some examples of machine learning are image recognition, speech recognition, medical diagnosis, statistical arbitrage, and so much more. The three different techniques used in machine learning are supervised machine learning, unsupervised machine learning, and reinforcement machine learning. Supervised machine learning uses past labeled data to predict the future of that data. So, it's kind of like stock market technical analysis. Unsupervised machine learning looks for previously undetected patterns in a data set with no pre-existing labels and with minimum human supervision. Reinforcement machine learning, also known as semi-supervised machine learning, is to take action in an environment in order to maximize the notion of cumulative reward. Industries that are using machine learning are financial, automobile, healthcare, agriculture, and retail and customer service industries. Supervised machine learning is used in financial industries for pattern recognition. In automobile industries, machine learning is used for product innovation. In healthcare industries, machine learning is used to streamline administrative processes in hospitals, map and treat infectious diseases, and personalize medical treatments. For agriculture industries, it is used for the productivity and quality of the crops. And finally, it is used in the retail and customer service industries by optimizing prices, collecting customer data, and making logistic processes more efficient. What is deep learning? Deep learning is a subset of machine learning. Deep learning is also known as deep neural learning or deep neural network. In deep learning, one would have to create an architecture called a multi-neural network architecture. Here are some pictures of multi-neural network architecture. To understand the complexity of the neural networks. Deep learning is when the machine is programmed to mimic the human brain. This connects back to the AI slide. Alexa and Siri machines are programmed to mimic the human brain. The most popular code language currently in deep learning is Python. What are multi-neural network architectures? The term multi-neural networks is used for strongly separated architectures. Each of the networks work independently on its own domain. The single networks are built and trained for their specific task. The final decision is made on the results of the individual networks, often called expert networks or agents. These are formed from trillions of neurons, nerve cells, exchanging brief electrical pulses called action potentials. This neural network is formed in 3 layers, called the input layer, hidden layer, and output layer. Each layer consists of 1 or more nodes. They are excellent tools for finding patterns which are far too complex or numerous for a human programmer to extract and teach the machine to recognize. There are 3 different techniques in deep learning. The first one is artificial neural network, the second one is convolution neural network, and the third one is recurrent neural network. These are all different types of multi-neural network architectures. Let me explain the details about these techniques in subsequent slides. Artificial neural network, or ANN, is an information processing model that is inspired by the biological nervous system, just like when the brain processes information. An example of ANN is that it is being used for stock market predictions, character recognition, image compression, and lots of other interesting applications. Convolution neural network, or CNN, would help solve codes in the form of images. An example of CNN is that they have been successful in identifying faces, objects, and traffic signs apart from powering vision in robots and self-driving cars. The picture outlined in blue is really helpful to understand CNN. When the computer sees the cat in its system, it actually sees the cat made up of numbers. Computers see the world in a different way than we do. Their world only consists of numbers. Recurrent neural network, or RNN, would help solve codes in the form of time series. Another definition is that where the output from the previous step is fed as an input to the current step. An example is that RNNs are mainly used for sequence classification, sentiment classification, and video classification. What is data science? Data science is the field of study that combines domain expertise, programming skills, and knowledge of mathematical and statistics to extract meaningful insights from data. It uses all the techniques that we have learned so far: artificial intelligence, machine learning, and deep learning. Data science uses some mathematical tools like statistics, probability, linear algebra, and so much more. A data scientist would have to work on machine learning and deep learning based on the type of use case using their mathematical tools. Data science uses everything we have learned so far in this presentation. Overall, data science is just the study of data. The most popular code language right now in data science is Python. Some examples of data science are identifying and predicting diseases, personalized healthcare recommendations, optimizing shipping routes, stamping out tax fraud, automating digital ad placement, and so much more. Python is currently the most popular code language. You might have noticed I have mentioned Python in my presentation several times. Python is a server-side language. This means that it is a programming language that is designed to run on a server. When browsing the web, your computer is considered the client. connecting to another computer referred to as the server. Server-side language is a programming language that runs on the server to process the client's request. It's an open source language. This means that it doesn't require any licensing to download, so you can download it for free. It is interesting to note that Python is one of the official languages at Google. Another advantage of Python is that it doesn't require a compiler, unlike the computer languages Java and C++ and C#. Just for your information, a compiler is a tool which is used to convert the text of a programming language called source code into machine code. Python is as easy as learning English. It is used for many applications in machine learning languages. In conclusion, I'm representing all of the 4 aspects in a simple diagram. If you consider artificial intelligence is the big circle, the machine learning is inside of the artificial intelligence circle, and the deep learning is inside of the machine learning circle. But data science is overlapping all of the 3 aspects. Well, that was my last slide. Thank you all for listening to me. Any questions?
Thank you, Deepika, for that amazing presentation about all those topics. So now if anyone has any questions, please type them in the chat. So the first question is, what is a good source for learning Python?
I used PyCharm. It was a really interesting and really useful source. It's really easy to use and it's free, so you can download it for free.
Okay, thank you for answering that question. The next question is, for AI, do we need to train the model before we start using it?
You can some artificial intelligent robots or computers you may have to, but others you may not.
Okay, and someone is asking again, what is deep learning? So do you want to just quickly summarize
Sure.
that?
Deep learning is a subset of machine learning, and you would have to create an architecture called a multi-neural network architecture. And deep learning is when the machine is programmed to mimic the human brain.
Okay, thank you for answering those questions, and also thank you for presenting. So our next presenter will be presenting about robotics and AI. So Arjun, you can start presenting.
Hello, my name is Arjun Parpelli, and I'm a rising 5th grader in Houston, Texas. And today I will be talking about robotics with AI. What is robotics? Robotics is the study of robots. Robotics is a versatile research area in computer science and engineering. Robotics involves the design, operation, construction, and the use of robots. Robots and robotics' main goal is to make human jobs and life easier. What is a robot? A robot is a machine. It is especially programmable by a computer. It is designed to perform a complex series of actions automatically. And robots can be guided by an external control device, or the control may be embedded within. This rover is controlled by both external and embedded control devices that are used to help the rover roam on the surface of the red planet. The history of the word robot. Karel Capek, the Czech novelist, introduced the word robot from the word robota in his 1920 hit play, RUR, or Rossum's Universal Robots. This image was taken after their play on the big stage. The word robot is drawn from an old Church Slavonic word or Czech word, robota, which means servitude or forced labor. The first robot. In 1954, George Devol invented the first digitally operated and programmable robot called Unimate. In 1961, the first industrial robot, Unimate, went online in a General Motors automobile factory in New Jersey. It was used to lift hot pieces of metal from die casting machines, and Unimate got placed in one of Kawasaki's museum-type exhibitions. Why do we need robots? Why are they so important? We need robots to do tasks over and over and over again with precision and accuracy, and they can work continuously without getting tired. And we use them to do things which humans prefer not to do. And robots can work in extreme environments where it is difficult for humans to operate. Types of robots. Mechanical bots come in all shapes and sizes to efficiently carry out the task for which they were designed, from the 0.2 millimeter long RoboBee to the 200 meter long robotic shipping vessel, Vinskip. Robots are emerging to carry out tasks that humans simply can't. RoboBee. RoboBees are insect-inspired robots with potential uses in crop pollination, search and rescue missions, surveillance, as well as high-resolution weather, climate, and environmental monitoring. Vinskip. Vinskip is a concept of a hybrid merchant vessel designed for sustainable sea transport driven by the wind and liquefied natural gas. Generally, there are 5 types of robots: pre-programmed robots, autonomous robots, teleoperated robots, augmenting robots, and humanoid robots. Pre-programmed robots. Pre-programmed robots operate in a controlled environment where they do simple, monotonous tasks. An example of a pre-programmed robot would be a mechanical arm on an automotive assembly line. The arm serves one function: to weld a door on, to insert a certain part into the engine, etc. And its job is to perform that task longer, faster, and more efficiently than a human. Autonomous robots. Autonomous robots operate independently of human operators. These robots are usually designed to carry out tasks in open environments that do not require human supervision. These robots are usually an example of autonomous robots would be the Roomba vacuum cleaner, which uses sensors to roam throughout a home freely. Teleoperated robots. Teleoperated robots are mechanical bots controlled by humans. These robots usually work in extreme geographical conditions and extreme temperatures. Examples of teleoperated robots are the human-controlled submarines used to fix underwater pipe leaks during the BP oil spill, or drones used to detect landmines on a battlefield. Augmenting robots. Augmenting robots either enhance current human capabilities or replace the capabilities a human may have lost. Some examples of augmenting robots are robotic prosthetic limbs or exoskeletons used to lift hefty weights. Humanoid robots. Humanoid robots are robots that look like and/or mimic human behavior. These robots usually perform human-like activities like running, jumping, and carrying objects, and are sometimes designed to look like us, even having human faces and expressions. 2 of the most prominent examples of humanoid robots are Hanson Robotics' Sophia and Boston Dynamics' Atlas. The AI side of robotics. What is AI? Artificial intelligence, or AI, is a branch of computer science. It involves developing computer programs to complete tasks that would otherwise require human intelligence. AI algorithms can tackle learning, perception, problem solving, language understanding, and/or logical reasoning. The benefits of artificial intelligence are that with AI, you can get fast decision making, the ability to solve complex problems, you'll get increased accuracy, and be able to perform high-level computations at fast speeds. Are AI and robotics the same? Well, the first thing to clarify is that robotics and artificial intelligence are not the same things at all. In fact, the two fields are almost entirely separate. As you can see, there is one small area where the two fields overlap: artificially intelligent robots. It is within this overlap that people sometimes confuse the two concepts. So robotics is kind of like the body, and AI is kind of like the brain. Types of learning in AI. How does AI learn? AI needs to learn to be intelligent by taking in lots of data and analyzing it. It also learns from previous experiences and takes it in to think about, like a baby learning how to walk. There are three main types of learning in AI: artificial narrow intelligence, artificial general intelligence, and artificial super intelligence. Artificial narrow intelligence, also known as weak AI, ANI, is the stage of artificial intelligence involving machines that can perform only a narrowly defined set of specific tasks, hence the name narrow. In this stage, the machine does not possess any thinking capability. It just performs a set of predefined functions. Examples of weak AI include Siri, Alexa, self-driving cars, AlphaGo, Sophia, the humanoid, and so on. Almost all the AI-based systems built till this date fall under the category of weak AI. Now do you see how AI plays a huge role in robotics? Artificial general intelligence. Artificial general intelligence, also known as strong AI. AGI is the stage in the evolution of artificial intelligence wherein machines will possess the thinking capability to think and make decisions just like us humans. But there are currently no existing examples of strong AI. However, it is believed that we will soon be able to create machines that are as smart as humans. Sophia is an exception though, because Sophia does not have the same thinking capability as humans, but it can perform more than a narrow set of predefined tasks, as we saw in the last section. So Sophia is kind of in the middle of ANI and AGI. Artificial superintelligence. Artificial superintelligence is the stage of artificial intelligence when the capability of computers will surpass human beings. ASI is a hypothetical situation as depicted in movies and science fiction books, where machines have taken over the world. Fun facts. Did you know that Sophia the humanoid from Hanson Robotics was the first robot to receive a citizenship? Accidental death. Did you know that the first known case of anyone being killed by a robot occurred in 1981 when a robotic arm pressed a Japanese Kawasaki worker? Cyborg 1.0. Did you know that the cybernetics professor Kevin Warwick calls him the world's first cyborg? With computer chips implanted in his left arm, he can remotely operate doors, an artificial hand, and even an electric wheelchair. Thank you for listening. Any questions?
Thank you, Arjun, for that amazing presentation about AI and robotics. So if anyone in the audience has any questions, please type them in the chat. So I see no questions. So it looks like you did a great job explaining it then. So thank you for presenting, Arjun.
Thank you.
The next presenter is from New Jersey, and he will be talking about how motors work. Take it away, Richard.
Hello, my name is Varshit Chakalam, and I'll be telling everyone how an electric motor works. An electric motor is a device that almost everyone has in their house. Table of contents. First, we'll know what an electric motor is, then what are the basics of an electric motor, and then what it contains. What is an electric motor? An electric motor is a spinning device that converts direct current, electrical energy, into mechanical energy. An electric motor is basically a motor that runs with magnets. When you turn on a motor, you can feel the spinning motion, right? This spinning motion is made by magnets. People use electric motors to run specific things in their house that use electricity, like table fans, toys, drones, brushes, hair dryers. These are normal things that you use in your house. If you want to know how an electric motor works, you have to know how a circuit and magnets work. The reason why is that the basics of an electric motor starts off there. Circuit. A circuit is a battery, wire, and a device that uses electricity. In this case, is a light bulb. Electricity flows through the wires. If there's a break in the wire, the flow of electricity stops. The path must be complete for the circuit to work. This is mostly known for using a switch. The electricity is flowing down the wire. We call this conventional flow. If you flip the battery around, the device that is using electricity still works, but some devices work depending on the way the current flows. Magnets. A magnet has a north and south pole. If you put another magnet next to it, the opposite attract and the same poles repel. Magnets that are narrow are called permanent magnets. They are called permanent magnets because they're always on or always working. Magnets do not have to be in this shape. For example, some magnets can be more flat, like this picture on the right. It is made out of magnetic domains that are lined up in one direction. Okay, so let's take one of our permanent magnets and let's drill a hole in it like this. Now we will take a magnet and put it on something that will allow it to spin. If you put a side magnet next to the spinning magnet, the same poles repel and the opposite poles attract. If you keep switching the side magnet, the spinning magnet will keep spinning. This spinning concept is really important. It is really important because this will basically make the spinning motion inside the motor. Electromagnet. Here we will start off with a metal bolt. A metal bolt is not a magnet and it still has magnetic domains that are pointing in random directions. If you take a wire and wrap it around the metal bolt and then create a circuit, the current through the circuit forces the magnetic domains to line up. If you take a wire, the electromagnet will do the same thing as a magnet. This means that it can attract the same poles and repel to the opposite poles. And also, we call this an electromagnet because a circuit uses electricity. And now the metal bolt is a magnet. So now it's an electromagnet. Now you can turn off the magnet by using a switch, which you cannot do with a permanent magnet. If you flip the battery around, that will make the magnet switch its places. The north becomes south and the south becomes north. This is called reversing the polarity of an electromagnet. Instead of flipping the battery, an easier way is to just flip the wires. Now we'll come back to the spinning magnet that we left off at. Now we can replace the magnet with the metal bolt. Let's just add the wires, and there we go. We made a magnet. Now the north is going to repel because the same poles repel and the opposite poles attract, which makes the electromagnet to spin. Now we will have to manually switch the wires so the metal bolt switches polarity, and that will make the electromagnet switch polarity so it spins again and again and again. Instead of doing that and make it easier, we can add another magnet to the other side. As you can see, the south is facing the magnet and the north on the other side. The side magnets will work together to spin the electromagnet. Improvements to the electromagnet. Instead of putting two side magnets to a bolt, we can put two circular magnets. Also, instead of a bolt with wires, we can put a metal loop, which is called an armature. Now let's connect the wires, and there we have now we have a circuit again. We'll have to think of the magnet as flat like this with the south side up. Now the magnets will line up until the opposite sides line up. Just like that. Since now, if the armature, we have to switch the polarity of the armature, so we have to manually sit there and switch the wires. So the polarity switches. And this is going to take us years. To be free of that, we will have to use a commutator. A commutator is an object connected to the metal loop, which is displayed on the screen. The commutator is a ring with gaps on the side. A commutator will spin along with the armature. Now let's come to the brushes. Now we can connect the circuit with the two brushes on the side. The brushes will not move with the commutator and the armature. They will slide along as the commutator spins. Now let's take a look into the brushes. These brushes are spring-loaded so they can stay close to the commutator. The current flows through the wire, the brushes, the commutator ring, the armature loop, and back. Now we have everything set up. And now let's get the armature spinning. But this time, when we come around, the brushes will switch contact to the other side of the commutator ring. Just like what's happening on the screen. And just to make sure that you guys know that this is happening on both sides because there are two brushes on the commutator. Before, the current was on the armature was flowing this way. This means the electromagnet, after the brushes switch place with the commutator segments, now the electricity is flowing this way. This means that the electromagnet just switched polarity from the south on the right side to the south on the left side. The commutator ring does the same thing that we did before, switching the wires, but this time it does it all by itself. This will keep spinning until it's connected to the battery. Take the battery out, no spinning and no electromagnet. Since now we have one loop on the armature, this will cause our motor to be stuck in this position. We're in the middle of the commutator segment. What we can do is we can add another commutator segment and another loop to the commutator, which causes it to start spinning. While spinning, they switch commutator segments, which turns on this commutator segment, and turns on this armature loop. And then while it spins, it's going to turn off this one and turn on the next armature. This keeps happening as our motor spins. Some electric motors will add many loops to the armature. The spinning force in the armature is called a torque, which is basically the commutator. Stronger torque means a faster spin. There are some things we can do to improve the torque. Now let's go and improve the torque. Improving torque. Did you know that electromagnets are stronger when there are more wires? This is true when we wrap more wires around the metal bolt. And it's also true when we have armature loops that have many wires in them. The motor will have a stronger electromagnet, which means it will spin faster. That's where the armature loops rest when the electromagnet is spinning. Let's take a look at real pictures of some electric motors. If you do see that it is filled with wires. The reason why is that more wires means more powerful motor. Now we can wrap up the electric motor in. The two magnets will rest on the side of the electric motor case. And there we will have to stick the axle out of the motor, which is that big stick that comes out of the electric motor. We can attach this axle to other devices so that it can run. Now when we pack it up, you can see the axle is sticking out of the motor's case. In summary, an electric motor is a device that people use to control devices that use electricity. A circuit and magnets are used in making an electric motor. They are the basics of the motor. A motor has a metal loop that goes through the middle, so the electromagnet can spin. The brushes in the motor are used to create electricity. Finally, we learned how an electric motor works, including the axle. Thank you. What I have just showed you about in this presentation is called a DC motor. Any questions?
Thank you, Varshit, for that presentation. So does anyone have any questions for him? If you do, please type them in the chat. So one person asked, what are the common reasons that a motor could stop working or fail?
It's the circuit, because sometimes if the wire is not perfect or the battery is wrong, it can actually stop working.
Okay. And then the next question is, how do we make the motor more powerful?
We can make the motor more powerful. We can make the motor more powerful by adding more armature loops.
Okay. Thank you, Varshit, for that presentation, and thank you for answering the questions. So I just want to let you know that you can find more details about future events and links to sign up as a presenter or as an audience member on stemfairs.com. And the next event is on August 9th. And so our next presenter will be presenting about math and computer science. So seems interesting, doesn't it? So you can start presenting, Akshay.
I'm sorry for the delay. I'm sorry.
Yeah, that's no problem. Take your time.
Okay, hello everybody. My name is Akshay Maram, and I'm going to 7th grade in Daniel Wright Junior High. Today I'll be presenting about math and computer science. In this presentation, we will learn different types of math and computer science. What are those maths and how do they help in computer science? And why math is necessary for computer science. Binary math. Binary math is the foundation of computer activity and one of the most common forms of mathematics used in computer science. Binary symbolizes every number inside the computer. The system, if binary, is an alternative for the decimal system. Use of this design simplifies model or design of the computer. Reading and basic mathematical operations are necessary to low-level hardware programming. The next type of math is college algebra. College algebra covers diverse concepts including linear equations, operations, exponents, polynomials, quadratic equations, rational expressions, radicals, proportions, and rectangular coordinates. It focuses on algebraic relationships, graphs, and functions, and in various complex equations, students learn to solve unknown variables for one or two. College algebra is a necessary topic for computer science. Statistics. Statistics is a type of math used in computer science that uses quantified models, representations, and synopses for a provided collection of experimental data, or actual studies. This field studies methodologies to obtain, review, evaluate, and form conclusions from data. Some statistical measures include mean, skewness, regression analysis, variance, analysis of variance, and kurtosis. Statistics are important in computer science because of the skills and data they can represent. Calculus. Calculus is the examination of continuous change and the ways change occurs. It handles the findings and properties of integrals and derivatives of functions. There are two types of calculus: integral and differential. Differential calculus deals with the rate of change of a quantity. Integral calculus determines the quantity where the change rate is known. Calculus is used in an array of computer science areas, including creating graphs or visuals, simulations, problem-solving applications, coding and applications, creating statistic solvers, and the design and analysis of algorithms. The next type of math is discrete math. Discrete math is one of the most important maths in computer science. For students who enjoy computers and have strong math and problem-solving skills, a career in computer science could be worth exploring. Discrete math is sometimes referred to as the math for computer science. Topics in discrete math that are used in computer science include graphs, recursive formulas, counting, logic, probability, and matrices. Discrete math methods may be used in designing algorithms and computer systems, as well as in software engineering. Discrete math examines objects that can be represented finitely. It includes a variety of topics that can be used to answer various tangible inquiries. It involves several concepts, including logic, number theory, counting, probability, graph theory, and recurrences. Discrete math provides an important contribution to computer science. Discrete math is used in various areas, including computer architecture, algorithms, computer systems, databases, functional programming, distributed systems, machine learning, operating systems, computer security, and networks. The problem-solving methods taught in discrete math are needed for composing complicated software. Specific math. The application for the program being created will often dictate the specific type of math techniques required. Linear algebra is often used for transformation of matrices. Matrix transformation is found in both 2D and 3D modeling, as seen in computer-aided design and photo editing software. Mathematics nature is good for computer science. Most concepts of math are taught through abstract language. On the other hand, one of the things that are covered in computer science is the study of programming languages. Most of these languages are also abstract in nature. They are characterized by syntax, well-defined processes, symbols, single words, and even visuals. Given the abstract nature of maths, you will have a smooth sailing when learning programming languages. Mathematics will impart a student with the art of reading, understanding, and analyzing a problem before coming up with a solution. All these skills are vital when it comes to programming and computer science in general. Math teaches us how to use algorithms. An algorithm is a commonly used term in the field of computer science and technology in general. It provides a basis under which any program or application should be created and implemented. Although most people encounter this term for the first time in a computer science class, the truth of the matter is they were introduced to it in a math class. You know that a simple equation such as 6 times 2 equals 12 or 3 divided by 6 is a half is an algorithm? From such simple equations, students are then introduced to complex algorithms in computer science. Analysis skills. Coding is not a one-way process. You have to keep coming back to inspect what you have written and verify whether it is correct. This is because you are bound to make one or several mistakes when coding. In the field of mathematics, students are usually forced to analyze their work. The answers that you might have given are not always accurate. You need to come back and inspect the formula and the figures that you have used. You will fix the mistake or errors before reaching out to your final answer. In other words, math prepares students for the tasks of identifying and fixing bugs. Even if there are tools that can do this job automatically, students will still have the zeal of doing this job effortlessly. I know analysis skills personally is very important in computer science because I have done a Python course, and you keep on having to verify whether your code is right because or else you'll get syntax errors. Math is just needed in computer science. Apart from the above skills, you will also encounter lots of maths in computer science. Here you will be required to use mathematics knowledge to solve real-life problems through a computer. Woe unto you if you never took your math classes seriously. For instance, there are lots of mathematical equations and formulas that are used to design a program for controlling a self-driven car. It will be very difficult, if not impossible, to write such programs if you are completely bad in the field of mathematics. Conclusion. Oftenly, most schools and colleges embed mathematics into computer science. However, they rarely inform students why they are doing so. They just do this as a basic routine. This makes students feel shortchanged. In this article, it is crystal clear that the theories of mathematics are practical. They can be applied to implement various core aspects of computer science. If you are planning to study computer science, maybe it is high time you build some passion for mathematics. Thank you for listening. Any questions?
Thank you for presenting about that, Akshay. So does anyone have any questions? If you do, please type it into the chat. I'm not seeing any in the chat so far, but let's wait another minute. Okay, so one question is only Python a good language? So does only Python use math, or do other languages also use math?
Multiple languages use math. Computer science in general is like a bunch of coding languages. I just told Python based on my experiences.
Okay. Yeah, those are all the questions I'm seeing in the chat. Thank you, Akshay, for presenting about this, and you did great. The next presenter will be presenting about DNA. Take it away, Akil.
Hey everyone, my name is Akil. Today, I'm going to share with you some of my knowledge about DNA. DNA is a fascinating topic for everyone to learn about. Today, we'll get into the basics, and I also created a tutorial for you for how you can extract your very own DNA. Let's get into it. Here's a quick agenda for today. First, we'll talk about what is DNA, followed by the history of DNA, the significance of DNA, the future of DNA, coming the tutorial of how to extract your DNA, some mind-blowing fun facts, and words to know. Let's get into it. DNA is made of molecules. You need to know that every living thing is made up of DNA, from huge elephants to tiny dust mites. Let's go over DNA's job inside our body. An amino acid is a simple organic compound in your body. There are 20 different types of amino acids, and they are often referred to as the building blocks of life. We'll get into that in just a second. DNA is made up of very long strands that can be read with a code. These are stored inside the nucleus of your cells. Another chemical in your nucleus is called RNA. RNA's job is to make copies of parts of your DNA and take it to the ribosome. The ribosome acts as the producer and reads the code from the RNA as can be read from the DNA. This code tells us what amino acid the ribosome should create, and the ribosome makes it into perfect shapes, and there are proteins. Proteins go on to make cells, cells go on to make tissues, and tissues go on to make organs. And there you go, you get a living organism. Now let's talk about the history of DNA. In 1869, Friedrich Miescher isolated DNA-associated proteins from the nuclei. That basically means DNA was discovered. It took almost a century, though, for scientists to realize the purpose of DNA and the power it beholds. In 1953, James Watson and Francis Crick discovered that the structure of DNA is actually a double helix. If you guys don't know what any of these words mean, hold your thought because I'll answer them in the end. In 1961, M. Nirenberg discovers the genetic code for protein synthesis. In 1977, F. Sanger develops the rapid DNA sequencing technique. In 1983, polymerase chain reaction was invented. This technology is used to amplify DNA. 1990 was the start of the Human Genome Project, and in 1999, chromosome 22 becomes the first chromosome to be discovered. In 2003, the Human Genome Project is complete, and 2003 to the present day. DNA is revolutionizing and helping many people's lives all over the world. So now let's get into why DNA is significant. First of all, DNA is vital for giving your body genetic instructions. As we talked about earlier, proteins have to be made into perfect shape and in order to function properly and help your body run. Well, DNA has created your body and now you're alive and you have grown to be a successful person with a lot of money. You may see where I'm going with this. So, one day your house is broken into and your money is stolen. If this were to happen about a century ago, then you're in a pretty big problem. Police will investigate the robbery, and after a certain extent, they would give up. Today, it's completely different. Let's walk through what would happen. DNA can be found all over your body. Criminals think they're smart by wearing gloves and masks, but actually, the only thing that protects you from is the coronavirus, not getting caught. Well, forensic experts come to the crime scene. They find evidence that the criminal may have left behind and take it to the lab. They cut the DNA from the evidence into two pieces and shoot electric currents through the DNA to create a pattern. They do the same with another part of DNA found at the crime scene. If the patterns of both evidences match, that person was definitely at the crime scene, and from there goes the interrogation and the next steps of investigation. This is really a much more efficient way. Now let's talk about the future of DNA. We talked about how DNA helps your body form and how it helps you with criminal justice. What if I were to tell you that DNA could have an even bigger important role in the future? DNA could store all the movies ever made into a tiny test tube. With everything on planet Earth becoming stored in data, it is very important. We use so much digital data that the digital storage has become very expensive. Once, scientists used the code in DNA to make a secret message and put the DNA strand on a letter and sent it. Now that's pretty impressive. But moving on, if we use DNA to store things like a secret code, we can even use it to store technology. In 2016, scientists were able to put 200 megabytes of computer files into DNA. DNA stands out because of the tremendous amount of data it can hold in tiny spaces. DNA is important in other cases, but data storage DNA could go a long way. The power of DNA could grow even stronger. Scientists are working on ways to bring back extinct species. You may be wondering, can you bring back dinosaurs? The answer to that is no. Dinosaurs became extinct 65 million years ago. DNA of an organism would become unreadable after 1.5 million years and break down after about 6.8 million years. So, dinosaurs can't be brought back. Woolly mammoths, though, only became extinct about 4,000 years ago. Possibly we can bring them back by extracting DNA from the remains of a mammoth. After this, we inject copies of the DNA into the womb of another species similar to woolly mammoth. In this case, would be an elephant. With that in mind, we could even bring back Neanderthals. If you don't know what they are an extinct species of the human race, as shown on the screen. You probably know that DNA has been known to save billions of dollars. Today, we'll talk about saving billions of dollars in just artwork. Experts estimate that over 40% of expensive artwork is fake. To combat this problem, scientists or the artists will put strands of a random organism onto the artwork rather than attaching the artist's own DNA. They will attach the DNA of an organism. So, because of this, frauds can't steal the actual artist's DNA and put it on their artwork, their counterfeit artwork, and claim it as real. This way, um, they will have a very hard time figuring out what organism is the DNA actually from. And now comes the fun part. Here's a video I made for you guys of how you can extract your very own DNA. After this event and you're interested, it'll be on Shrieker's YouTube channel, and play this video as much times as you would like to know what to do. So here we go.
So, hello guys, I hope you are enjoying my presentation so far. So, in this experiment, we're going to be extracting your very own DNA. So, what we're going to be needing is chilled isopropyl alcohol, dish soap, 2 empty glass bowls, 1 glass bowl with water, about 2 spoons of salt, 1 spoon, and some food coloring. So let's get right into it. So with the cup that has water, we're going to dump the salt inside. And we're going to stir it nicely for at least 30 seconds. So guys, we are done mixing. And so we're gonna set the spoon aside. And so what we're gonna do is take this salt water, put it in our mouth, and gargle it. We're gonna spit it in this if you're not able to, put all of this water in your mouth at a time. So guys, I spit it out in here, and so the purpose of this is when you gargle the water in your mouth, it collects cheek cells from your cheek, and now it's there. So the next step is going to be adding some chilled isopropyl alcohol into a separate glass of water. So now that that is added, we're just going to add a few drops of food coloring into it. And that should be good. Next, we are going to put some dish soap into our gargled water mixture. Come on. So now guys, we have added our dish soap in, and now it's time to mix both of our solutions together. Now that we are done with that, we're just gonna sit and wait for 4 minutes. And you can stir it if you would like. So see you in 4 minutes. So guys, if you look really closely into the bowl, you can see some strands of DNA. Let me give you a closer look. There's a lot in there actually, it's just not coming into the spoon. But like, here. Oh, it keeps slipping. So there it is guys. So now let's go on to talk about the science of what actually happened. So when we gargled the salt water, it actually took the cells from my cheek, as I said earlier. So now that's in the bowl with the rest of the water. When you add the dish soap breaks through the nuclei of your cheek cells, and then after you add the isopropyl alcohol, it comes out and is visible to the naked eye. So I hope you enjoyed my presentation, and feel free to try this experiment at home. Thank you for watching.
So, guys, it was a very simple experiment, and all you need is stuff that you normally have at home. So, I'm sorry, I may have said to put the isopropyl alcohol into a glass of water at the beginning, but it's actually should be an empty bowl. So, here on the screen, you can see I had a hard time getting it onto the spoon, but we finally managed to get it, and it looks pretty cool. So here's some incredible fun facts. Your DNA could stretch from the Earth to the Sun 600 times. All humans are 99.9% alike. Genes make up only 3% of our DNA. You could be more related to Irish, Australian, or even South African than the amount of genes you're related to your own siblings. All the DNA in your body is as long as 10 billion miles. The DNA in your body gets damaged at least 100 times a day, but it gets fixed easily by our body. It would take you 50 years to type the entire human genome at a speed of 60 words a minute, 8 hours a day, every day. And here are some words to know. Double helix is the shape of DNA. Genetic is the information in our body that affects our personality and look. Molecule is a tiny substance that all things are made of. Nuclei is the central part of a cell that controls its activity. Protein synthesis is the process of making a protein. Polymerase chain reaction is how you make copies of a sequence of DNA. The Human Genome Project was an international research project to determine the base pairs of human DNA. Forensic science is a blend of biology, chemistry, and physics to solve crimes. Chromosome 22 is one of the 23 pairs of chromosomes in human cells. Ribosome is a part of your body that produces amino acids into proteins. Thank you for watching. Do you have any questions?
Thank you, Akil, for that amazing presentation about DNA, and your demonstration was also great. So if anyone has any questions, please type them into the chat. Okay, so instead of the alcohol making the in like the demonstration, I believe they're asking for, is there like a substitute for that instead
Well,
of
like
using that?
based on my research, like there are many different methods to do it, but like in the method I did it, alcohol was like a simple, like it was like a very simple choice, and it has the best effect, and you can easily find it in Walgreens and any local pharmacy.
Okay. The next question is, what does it mean when someone can be more Australian than their own siblings?
Oh, so like I'm sorry if I didn't explain that like more clear, but like if you're Australian, you have a certain genes like of how your personality is, or more like your look. So like for example, sometimes you can have more of those genes than the genes compared to your own siblings.
Okay, thank you for answering that. The next question is, are there different types of DNA?
Um, well, I don't really think so. Like no.
Okay. Yep, thank you for answering all those questions. And once again, thank you for presenting, Akil.
Thank you.
The next presenter is Shripad. He will be presenting about 3D printing. So take it away, Shripad.
Hi, my name is Shripad, and I'm from Chicago. My presentation is all about 3D printing. What is 3D printing? 3D printing is a process in which multiple layers of material is created until the object is made. Fusion 360, Autodesk Inventor, AutoCAD, SolidWorks, and GradCAD are all softwares that you can use to make 3D models for a 3D printer. 3D printing allows to produce very complicated and detailed shapes that you can't normally create, along with making the objects hollow. 3D printing makes manufacturing better, easier, and cheaper. It's also very easy for the user to use these softwares and design something cool. What can you make and what materials can you use? You can make many things with 3D printing. It's easy for manufacturers to make consumer items/machines and industrial items/machines based on 3D designs. We can even make basic consumer items ourselves since it's very simple to make these things and many files can be found on the internet. Prototype models are also a good use for 3D printing since the material can be cheap. Toys can also be made by consumers or manufacturers. You can also make anything else that you can create. 3D printers use many materials like ABS plastic, titanium, wax, silver, nylon, steel, gold, and any other material that can change forms. The smoothness and strength of a 3D printed machine is based on the material used. On the right is an image of a roll of PLA filament. Pros and cons of 3D printing. There are a lot of pros for getting 3D printers, but there are also some cons. It's not very hard to use a 3D printer once you learn the basics on designing and slicing. After that, you can make some really cool things. The ability to explore and experiment allows you to improve your models and get a better understanding of what you can make. Some of 3D printing is the price. A decent 3D printer can cost hundreds, and good ones can cost thousands. Some materials can cost a lot too, though if you choose to use plastic, it's fairly cheap. Making complex models also requires a powerful computer. These are some of the main downsides for the average consumer, although manufacturers shouldn't have much of a problem with this cost. The history of 3D printing. Charles Hall first came up with the idea of stereolithography in 1983 when he was hardening coatings on a table with UV lights. He then filed a patent on stereolithography, also known as 3D printing. The patent said that a 3D object could be made from printing multiple layers of ultraviolet curable material repeatedly. Hall founded 3D Systems in 1986, where he then realized that any material capable of solidification or material capable of altering its physical state could be used. This is just the start of 3D printing. After this, 3D printing was mainly used in the manufacturing, engineering, and agricultural industries. Uses for 3D printing in the medical field. 3D printing can be extremely useful in the medical field. Since many medical items are very expensive, 3D printed objects are a cheaper alternative than traditionally manufactured items. 3D printed silicon N95 mask. During this COVID-19 pandemic, many people are unable to buy masks due to stock and high prices. There are files on the internet for people to make their own by 3D printing it. Companies with industrial grade 3D printers have also started to make parts for masks. There's also 3D print files on the internet where you can print a frame, and in there you can attach it to a respirator piece and then attach it to a piece of fabric. 3D printed prosthetics. 3D printing can be used to make prosthetics specific to a patient's needs. It also takes much less time and money than traditionally manufactured prosthetics. The fit of the prosthetics are often much better too. On the right is a picture of a 3D printed face mask. Uses for 3D printing in the medical field Part 2. 3D printed surgical instruments. They're less money than instruments normally are. They're also easily modifiable. 3D printed face shields. And again, due to the pandemic, face shields are in high demand. The frame for it can be printed easily and efficiently. Rapid prototyping. Rapid prototyping is a process in which designers make the product in CAD at full scale and then 3D print it or use other additive layer manufacturing techniques to make the part or parts. This is quite a good method as it is fairly cheap and easy to make for the manufacturer, so they can easily improve or change aspects of the design if needed. There are also downsides as 3D printers are not as accurate as traditional machines, and the part strength cannot be tested and they tend to be weak. So rapid prototyping isn't the perfect method, but in most cases a great one. The future of 3D printing. Besides the large number of recent innovations in 3D printing and the pros to 3D printing, there is still much that can be done to improve 3D printing and access to it, namely the price of 3D printers, and often the cost of machinery such as powerful computers is still very high, creating an issue with trying to innovate and learn about these useful machines. Eventually, as it becomes cheaper to produce 3D printers, hopefully the price will also go down and people from all over the world, not just major countries, can have access to these machines and do something great with them. In the future, many can envision that large-scale 3D printers have a key role in humanitarian relief and aid or in homelessness. With 3D printers, small-scale homes can be constructed quickly and cheaply. This could revolutionize how countries in poverty could change their lifestyle. And when hurricanes or tornadoes strike, 3D printers could be used to create needed emergency equipment or repair equipment. This is simply the beginning of what 3D printers could do, and they still have a lot of potential in what can be created with them. The picture on the right is a house constructed with a cement 3D printer like machine, and it only took 24 hours and $10,000 to build it. Next, there's going to be a demo on how to make basic models in CAD.
Hello and welcome to the demo portion of the 3D printing presentation. So to 3D print, you need to create designs in a software. Today we're going to be using Autodesk. So we're here on Autodesk.com, and if you go to Products, Product Design and Manufacturing Products, click there. And now if you scroll down, you'll see all of the different softwares that Autodesk has to offer. Today we're going to be using Inventor, which normally costs money, but if you have a .edu student email, you can get it for free. Inventor requires a powerful computer, but for small designs, any computer can really be used. So let's go into Inventor, and if you click New, you'll see 4 different types of files, and the first one is Part, where you can create 2D and 3D objects. Assembly is where you can assemble your different parts together, and drawing and presentation are just places where you can showcase your assembly, and you don't need this for 3D printing, so we're not going to be showing that. So let's create this standard part, and on your left you'll see the tree of all the things applied to it and actions you took, and then here you'll see the pivot tool and you can change your angles. So here let's click Start 2D Sketch, and then here's your 3 different planes. We're going to be using the X-plane, and here are shapes. So I'm going to make a square. Now it doesn't really have to be a square because I can change the dimension. As you can see with the dimension tool, I can make it whatever I want. I'm going to make it 1. And let's do the same with this. And now we have a basic 1x1 2D image. So when you click Finish Sketch, you'll see it puts you in a 3D plane, but you don't have a 3D image. So you have to click Extrude, and then you can select the distance you want it to be. I'm just going to use 1 inch. And now let's move it into place. Okay, so now we have our basic cube. It's a very basic object, and there's different things you can do to it, like fill it. And if I select that, it just curves it, and you can select the radius of the curve, like 0.5, and you'll see that's much more of an angle. I'm going to stick with 0.125. So now another feature is shell, and it basically like hollows it out, and then you can choose the thickness. So let's say I want to put it on this side, I can choose the thickness of that. I'm going to leave it as 0.1 inches. So now we have our basic object. So let's say you could 3D print this. So you could export it into a different assembly, but let's say you want to add a different shape to this as one part. You would just go there and select whatever side you want, and then click Start 2D Sketch, and now you can add another part to it. Let's show you that here. Let's just create a circle, and now when you click Finish Sketch, you can go here and use the Extrude tool to attach it to this cube. So now you've got this shape. So this is gonna all come up as one part, which means that you don't have to combine them in the assembly phase. So let's save this quickly. Save that. And now if I make a new assembly, make sure it's standard. It's going to open a new assembly, and then you just click place, and now if I find the part, this seems to be it. And this is an important step. You have to right click and then click place grounded at origin. So now here you can see that this is the assembly phase and it's all assembled. That's really all there is because I'm only using one part. So now if you wanted to 3D print it, you would have to just save it as a file, and then you would have to use slicers, and there's different softwares from each company with slicers. The slicers allow you to um, like customize what material you're using, the model size, the heat bed, and a lot of other things. And that would be the final step before 3D printing it. And after that, you could 3D print it. And that's basically how you make 3D models using Autodesk Inventor. And that's the end of this demo.
Thank you for watching. Any questions?
Thank you, Shripad, for presenting about 3D printing. So now if anyone has any questions, please type them in the chat. So the first question is, what size of objects can we print?
Well, that depends on which 3D printer you have. Each 3D printer will have a different size bed where you can where it prints the objects. So it depends on which model 3D printer you have.
Okay, thank you for presenting, Shripad. You did a great job. I hope everyone had a great time, and I hope you all learned something new. We have over 60 viewers who joined and watched the event on Zoom, and over 15 viewers on YouTube Live. I'm seeing many thank you messages, and I'm glad to see them. It was my pleasure to organize the event. In the next month, there will be a third STEM fair on August 9th, and there are also going to be more future dates coming soon. Here is a sneak peek at some of the topics coming up in future events: gas versus electric cars, computers, what the universe expands into, and self-driving cars. These are just some of the topics that are going to be coming in future events. And if you want to sign up as a presenter, you can go to stemfairs.com for the information and for the links to sign up. Currently, the slots for the August event have filled up, but you can still sign up for more future events. If you have not yet signed up as an audience member and want to watch future events, the sign up information is at my website, stemfairs.com, and you can also check out my YouTube channel, STEM Explorers. I will post the event recording there, so if you maybe came late or if you want to rewatch someone's presentation, you can go to my channel, STEM Explorers, and you can see it again. During the last event and afterwards, many asked me about how to sign up and what my process was on how I helped the presenters through the process and how I helped them create their presentations. So I thought that I could answer those questions by providing some details for everyone. So first, a bit about me. I am a rising sophomore and I have been presenting since 4th grade in various SIT conferences and maker fairs. I am also on my school's VEX Robotics team and I love exploring new technologies and coding and doing CAD. So why am I doing this then? Well, as I said before, I wanted to bring other students the same opportunity of presenting about STEM even during these special circumstances, and now I am organizing these events online. So now let's get into the process of signing up and how to be a presenter. So let's begin at my site, stemfairs.com. It has all the information about the event and links to sign up. So let's go to the website. So this is my website, stemfairs.com, and here you can see the homepage, and then scroll down to site content to go to sign up, and then you will be taken to a sign up page where you can sign up as a presenter. And then you can simply go through the form, and then I will contact you and I will help you choose a topic. So now back to slides. So for those who sign up as a presenter, the first step is choosing a topic. It can be any STEM related topic, and the topic has to be important to the presenter. So if they ask me for a topic, I ask them what they are passionate about and what they want to learn more about. And as I said, if you need help choosing your topic, I can guide you through that. The second step is to research about the topic. Use good sources and maybe even some different articles or scientific papers. And if a presenter has trouble starting their planning or finding additional sources, I can help you with those issues. And the third step is to make the actual Google Slides. I will send out a YouTube video in which I explain how to make proper slides for those who need that guidance and help. I also explain various things such as what slides to use for your topics or how to format it properly. I also check each presenter's slideshows multiple times, and I send them the feedback so that they can improve their slides. The presenters also practice their presentations very often. I then conduct 2 practices prior to the event. So that's basically how the presenters start at choosing a topic and then how they end up eventually presenting. So now let's take a look at the virtual thank you card from the virtual STEM Fair presenters. We are creating this card to send a thank you message to the healthcare workers who are on the front lines of battling the COVID-19 pandemic and during this pandemic. We will be sending it out to various healthcare teams. We had a great event today. Thank you everyone for attending the second virtual STEM Fair. Thank you to all the presenters for presenting and making it a great event. I hope to see you all on the next event on August 9th. Bye everyone, and thank you for watching.